Good morning, everyone. Hopefully you're doing well. In this video, we're going to find the slope of a graph at a given point using implicit differentiation. So first of all, let's start by finding the implicit differentiation of that function for x plus 4y cubed equals 64x cubed plus 64y squared at the point negative 1, 1. So the first step is really to find the implicit differentiation. When we have expressions like this for x plus 4y cubed, we can see that it is in the form u n prime, it's n u n minus 1 times u prime, right? So now let's take the derivative of the first of the left hand side. So that's going to give us we bring the 3 in the front. We keep the inside as is. Now 3 minus 1 is 2. Now, what is the derivative of the inside? The derivative of the inside, remember, we're taking the implicit differentiation. That means we need to take the derivative with x, and we take the derivative of y with respect to x. So we have 4 when we take the derivative of x, and we have 4 when we take the derivative of y. But when you take the derivative of y, you need to add the dy dx. Now, in the other end, 3 times 64x squared plus 3 times 64y squared dy dx. Okay, now let's distribute. We can have 3 times 4 is 12. We're going to have 12 4x plus 4y squared plus 12x 4x plus 4y squared dy dx. We distribute. In the other side, we have 3 times 64 is 192 x squared plus 192 y squared dy dx. Now we're gonna combine, we're gonna bring all the dy dx in one side and the other terms in the other side. So we have 12 4x plus 4y square dy dx minus 192 y squared dy dx. Now bring everything else in the other side. 192x squared minus 12 4x plus 4y squared. Okay, what we see here, we can factor out. We see that 92, if you try to divide 92 and 12, do they have a common factor? Yes, 92 and 12 has a common factor because 12 times 16 give you 92, so we can factor 12. We factor 12, so we have 4x plus 4y squared left in this side. If you put 12 outside, you have 16 y squared left, and we can write dy dx. And in the other side, we're gonna do the same. We factor 12, so we have 16x squared minus 4x plus 4y squared. Okay, you see 12 both sides. You can you can cancel it out, but if you don't see it, we can rewrite now. So we have our dy dx. That would give us 12. Do you agree we can rewrite 16x squared as 4x power 2? And we have 4x plus 4y square over 12 outside And we're going to do, because we multiply both sides by the coefficient of dy dx. Now you see on the left-hand side, we only have dy dx, and in the right-hand side, we have a numerator and a denominator. So that would be 4x plus 4y square minus, for 16y square, I can also write it y, 4y power 2. Okay, the first step here is really to simplify by 12. You see we can simplify by 12. Also, we see the form we have on the top and the bottom is like we have a square minus b square. Remember, a square minus b square, what it gives you. So if you have a square minus b square, that gives you a plus b, a minus b. So we see that's exactly what, when we cancel out by 12, we have in the top left, in the top, what we have is 4x plus y, 4y, 4x minus 4x plus 4y. That's the top one. And we're gonna do the same thing at the bottom. We have 4x plus 4y plus 4y, 4x plus 4y minus 4y. Now we can distribute if we want. So we have our dy dx. How would that be? That would give us in the parentheses up there, let's remove the parentheses, 4x plus 4x plus 4y. Now the other one would be 4x minus 4x minus 4y. We remove the parentheses. At the bottom, we're gonna have 4x plus 4y plus 4y. And then we have 4x plus 4y minus 4y. When you simplify, in the first parentheses, what you see, we have 4x plus 4x give us 8x plus 4y. Now the second parenthesis, 4x minus 4x is gone. We have negative 4y. The denominator, 4y plus 4y give us 8y. So we have 4x plus 8y. And the second parenthesis, we see what happened. We have 4x and 4y minus 4y, we only have 4x left. Okay, all of them has 4. That means we can, we can go over here and continue because we don't have enough space at the bottom. So dy dx would give us, now let's simplify. We can factor 4. Okay, so let's factor 4. So we have 8, we no longer have 8 because if you factor 4, you have 2x left plus y times negative y because we factor 4. And the bottom one, we also factor 4. So we have x plus 2y times x. Now, when we cancel out the y, the 4, we have negative y times 2x plus y over x times x plus 2y. So our dy dx is equal to negative y. You can either distribute it or we leave it like this. If you distribute, it's gonna give you negative 2xy minus y squared, but I prefer to keep it that way. 2x plus y over x over x times x plus 2y. So let's keep this one as our derivative. So the derivative, the implicit, this is the implicit differentiation. Now, part B of the questions is asking you to find the slope. Find the slope. How do you find the slope? Well, you just substitute because find the slope at the point. At the point. What is the point? Is negative 1, 1. That means in the derivative, let's call I like to call this slope m. I'm going to call this slope m. Find the slope m at the point. All right, so if I call the slope m, that means everywhere is like, for me, is taking the derivative, plugging that coordinates in the derivative. That means everywhere in the derivative, you see x and y, you're gonna replace x by negative 1 and you replace y by 1. So we have negative 1 times 2 times negative 1 plus 1 over negative 1 times negative 1 plus 2 times 1. Well, actually, once you do everything, as you see, the first one become positive, but inside of the parentheses, you end up having negative 2 plus 1 over negative 1 plus 2. So m would be equal to negative 1 over 1. So the slope m is negative 1. All right, so I hope you use these examples to find more slope of the graph having at a given point using implicit differentiation. Don't forget, if you have any questions, do not hesitate to contact me, and you can also subscribe to these channels for more video. We have videos in different folders for pre-calculus, calculus 1 and calculus 2, and we're gonna continue to add for algebra. Hope you have a good day. Enjoy.